Final review, Part 1. Number 1. Limit x approaches to 4 of quantity 3x squared minus 11x minus 4 over quantity x minus 4. I can see already if I were to plug x equal 4, my denominator is 0. So let's plug it into numerator to see what happens. So if I plug it into numerator, I get 3 times 4 squared minus 11 times 4 minus 4 over 4 minus 4, and I do get 0 over 0. Let's say you already ran the calculator, so you can see that you get 0 on the numerator. And when we get a 0 over 0, we learned in chapter 1 that we would factor, rationalize, and simplify complex fractions, and then we get to plug x value in there. So since this is a polynomial over a polynomial, we would suspect that this guy factors. So I'm gonna try to factor to see if I can plug it in there. And another thing is, because you got 0 over 0, actually you could use L'Hopital's rule now, since you know how to do L'Hopital's rule, which probably is faster. Anyways, because it's a review, I'm just going to use the factoring, since we do have our L'Hopital's on the other problems. So if you factor, you get limit x approaches to 4 of, your numerator does factor, and it factors as 3x plus 1 times x minus 4 over x minus 4. So that x minus 4 factors would cancel, and all I have to do is to find out limit of 3x plus 1. And now you can plug x equal 4. You get 3 times 4 plus 1, which is equal to 12 plus 1. So you do get 13. So the first one answer is 13. Second problem, because when I plug x equal negative 2 in the denominator, it's not 0. So I'm going to do direct substitution and plug x equal negative 2 to see what happens. And if I do, I get 2 times negative 2 squared minus negative 2 minus 10 over negative 2 minus 2, which is equal to then 4 times 2 is 8 plus 2 minus 10 over negative 4. I get 0 over negative 4, which is 0. So limit is just 0 since I plug it in and I get a number, and that will be the limit. And the third one, I have an absolute value function. We did the absolute value function so many times this semester, and whenever you see absolute value, first thing you want to do is rewrite this function as piecewise defined function. So I have an absolute value of x minus 3, and you want to rewrite that as it is x minus 3 if x minus 3 was greater than or equal to 0, which means x is greater than or equal to 3. And I should not include the 3 actually, because my absolute value function is in the denominator. So we don't want it to be equal to 3, because actually at 3 this function is undefined. So let's actually get rid of equal sign, and it will be opposite of x minus 3 if x was less than 3. So now we are actually finding out limit x approaches to 3 from the left. So this is a number line and this is 3. So 3 from the left is numbers less than 3. And because number less than 3, we need to apply this function when we want to get rid of absolute value. So this will be x minus 3 over opposite of x minus 3. So that x minus 3's get canceled, and you have a limit x approaches to 3 from the left of negative 1, and limit of a constant is a constant. So limit x approaches to 3 from the left of x minus 3 over absolute value of x minus 3 is negative 1. Number 4. Limit x approaches to negative 2 from the right of absolute value of x plus 2 over x plus 2. Again, we have an absolute value function. So let's rewrite it. Absolute value of x plus 2 is just x plus 2 if x was greater than or equal to -2. And again, I do see x plus 2 in the denominator, and if I plug -2, I get 0. So this function will be undefined at x equal -2. So I'm going to actually get rid of -2 there. And then it is opposite of x plus 2 if x is less than -2 then, right? And right now, this is where -2 is, and x is approaching to -2 from the right. And from the right, all the x's are bigger than -2. And because it is greater than -2, I have to apply to this function when you get out of absolute value. So limit x approaches -2 from the right of absolute value of x plus 2. We said we're gonna use x plus 2 over x plus 2 is 1. So this is limit x approaches to -2 from the right is 1. And limit of a constant is a constant. So this limit will be positive 1. Number 5. Limit x approaches to 5 of quantity 4 minus the square root of quantity x plus 11 over quantity x minus 5. Again, I can see if I plug x equal 5, my denominator is already 0. And I also see, even if I plug it into numerator, x equal 5 there, square root of 5 plus 11 is 16. Square root of 16 is 4. 4 minus 4 is 0. So I get 0 over 0 again. And with radical in there, we had a special technique, which was rationalizing. So let's go ahead and rationalize the numerator to see if we could do the direct substitution for x equal 5 afterwards. So then this is equal to limit x approaches 5. I'm going to multiply 4 minus the square root of x plus 11 over x minus 5 by the conjugate of numerator, that is quantity 1, which means I would like to multiply 4 plus the square root of quantity x plus 11, both the numerator and the denominator. So then my numerator is a minus b times a plus b, which is a squared minus b squared. So when you square the 4, you get 16. When you square the radical goes away. But don't forget to put a parenthesis there since you are subtracting everything inside of a square root. And now my denominator is x minus 5 factor times 4 plus radical x plus 11. And my numerator, when you distribute the negative, you get negative x minus 11. So you get minus x plus 5. So you get limit x approaches 5 of negative x plus 5 over x minus 5 times 4 plus the square root of quantity x plus 11. But negative x plus 5 and x minus 5 are opposite. So you can cancel, but because they are opposite polynomial, you will get quotient negative 1. So limit x approaches to 5. Like I said, you can cancel them, but you're going to have negative 1 factor in there. So you have a negative 1 over 4 plus radical quantity x plus 11. Now, you can plug a 5 for x. So you have a negative 1 over 4 plus radical 5 plus 11, which is negative 1 over 4 plus radical 16. Radical 16 is 4, so you get negative 1 over 8. So we found our limit. And answer will be A for this multiple choice. Number 6. Limit x approaches negative 3 from the right of quantity x minus 3 over quantity x plus 3. I can see that if I plug x equal negative 3, I do get 0 in the denominator, but not on the numerator. So this could be vertical asymptote. So it is critical to see if it goes to infinity or negative infinity. And by calculus definition, if this limit goes to infinity or negative infinity, you have a vertical asymptote at x equal negative 3. So let's actually find that out. Because x is approaching to negative 3 from the right, you could plug a number like negative 2.99999, something like that. So if you were to plug negative 2.99999 for x, your limit x approaches negative 3 from the right of x minus 3 over x plus 3 is, on the numerator, I could just plug a negative 3 there. So I will get negative 6 over. And if you plug negative 2.9999 plus 3, I get number close to 0. That is a positive number. And because you have negative fixed constant on the top over, you get 0.000000001 or something like that. You know, number is going to negative infinity. So you actually do have VA there. You were asked to get the one-sided limit of this function as x approaches to negative 3 from the right. So the answer is negative infinity E. Number 7. Limit x approaches negative 1 of 2x minus 3 over 2x squared minus x minus 3. When I do direct substitution, I will get 2 times negative 1 minus 3 over 2 times negative 1 squared minus negative 1 minus 3, which I get negative 5 over 0. And because this is not a one-sided limit, we know even though we have a vertical asymptote there, we don't say this is infinity or negative infinity. When they're just asking the limit, whether left limit is plus minus infinity or right limit is plus minus infinity, we do say then limit does not exist. So the answer for this problem would be does not exist. Number 8. Limit x approaches to infinity of 6 over x over e to the 1 over x power minus 1. So what happened as x approaches to infinity? Where does 6 over x approaches to? As x approaches to infinity, 6 over x approaches to 0. And also, as x approaches infinity, 1 over x approaches to 0, and e to the 0 is 1, and 1 minus 1 is 0. So I do have 0 over 0 here. So let's use L'Hopital's rule, and that would be limit x approaches infinity. I want to take the derivative of 6 over x. 6 over x is 6 times x to the negative 1 power. So when you take the derivative of that, negative 1 power comes down. You get negative 6 times x to the negative 2nd power. And e to the u minus 1, when you take the derivative, it is e to the u. So you get e to the 1 over x times u prime is 1 over x prime, and 1 over x is just x to the negative 1. So when you take the derivative of x to the negative 1, I just get negative x to the negative 2nd power, and derivative of negative 1 is 0, so that's all I get in the denominator. And I have a negative over negative, so these can be cancelled. And then I could cancel x squared factors, x to the negative 2nd power factors. I can cancel them. So all I have now is limit x approaches to infinity of 6 over e to the 1 over x power. So now when I apply x approaches to infinity, it is 6 over e to the 0's power, and e to the 0's power is 1, so my limit is 6. So your answer will be d here. Number 9. Limit x approaches to infinity of ln x over 3x. So by now, hopefully you guys remember ln x graph. If you don't, you better memorize it now. So this is y equal ln x graph looks like. And you can see as x approaches to infinity, ln x approaches to infinity as well. So ln x goes to infinity, and as x approaches to infinity, 3 times infinity is infinity. So we have infinity over infinity. So how are we going to find the limit of this? That's right. You use L'Hopital's rule. And this limit will be equal to then limit x approaches to infinity of derivative of ln x was 1 over x. Derivative of 3x is 3. When you simplify, this is limit x approaches to infinity of 1 over 3x. So what happened when you send the x to infinity? You get 1 over infinity, and constant over infinity goes to 0. So your answer will be A. Number 10. Limit x approaches to infinity of quantity 1 plus 1 over x to the x's power. So let's see, that looks very familiar to me. And if you send the x to infinity, 1 over infinity goes to 0. So this becomes 1 to the infinity's power. Yes, this was another indeterminate form. And we use L'Hopital's rule, but this is a little bit different. When we have 1 to the infinity, what we did was we let this limit equal L. So L equal limit x approaches to infinity of quantity 1 plus 1 over x to the x's power. And the next step was, yes, we took ln both sides. And then your next step after that was you switch limit and ln notation. So you have a limit x approaches to infinity of ln quantity 1 plus 1 over x to the x's power. And now we use beautiful property of logarithm, which the power of input of logarithm drops down to the front. So we have ln L equal limit x approaches to infinity of x times ln of quantity 1 plus 1 over x. Okay, now if you look at this limit now, when you send the x to infinity, x goes to infinity, and as x goes to infinity, 1 over x goes to 0. So you get ln 1, and ln 1 is right here, which this point is 1, 0. So ln of 1 is 0. So we are going to try to rewrite this expression as 0 over 0, so we can use L'Hopital's rule. Why 0 over 0? Because we would like to leave the ln 1 plus 1 over x on the numerator so that it will be easier to take the derivative of. So we're going to rewrite this as ln L equal limit x approaches infinity of, let's write as a fraction, so we can have a 0 over 0. We know already ln of 1 plus 1 over x goes to 0, and x goes to infinity, but now we're going to put it on the denominator, so it's going to be rewritten as 1 over x. So now x goes to infinity, 1 over x goes to 0, so now I have a 0 over 0, so you get to use L'Hopital's rule. So I have ln L is equal to limit x approaches to infinity of derivative of ln of 1 plus 1 over x is, since 1 plus 1 over x is u, it is 1 over u is quantity 1 plus 1 over x times u prime, and u is 1 plus 1 over x. Derivative of 1 is 0. Derivative of 1 over x, which is x to the negative 1 power, is negative x to the negative second power. And my denominator is 1 over x, so I know derivative is negative x to the negative second power. So now I can cancel these. And of course, negative over negative becomes a positive. So now all I have is ln L equal limit x approaches to infinity of 1 over 1 plus 1 over x. So now if you send x to infinity, 1 over x becomes 0. So I have 1 over 1, which is 1. But that's not the answer, right? So don't choose 1 here. Don't jump on it. What you have is ln L equal 1. And remember, your limit, we call it an L. This is an L. So we have to find is an L, not ln L. So we need to change this to exponential expression to recover L. So L will be equal to, the base was e to the first power, which is e. So actually, this is the answer, right? Since that's what the L was. So your answer choice here is C. Number 11. Limit theta approaches to pi over 2 from the left of tangent theta minus secant theta. So here's the graph of tangent theta from negative pi over 2 to pi over 2. This is what tangent theta looks like. And now secant theta is above cosine theta. So again, between negative pi over 2 to pi over 2, here is how secant theta looks like. So as theta approaches to pi over 2 from the left, you can see it is going to positive infinity. So this will be positive infinity minus, as theta approaches to pi over 2 from the left, secant theta also try to reach to infinity. So you have an infinity minus infinity, which is another kind of indeterminate form. So what we would like to do in this case is try to make a rational function so that we can have either 0 over 0 or infinity over infinity, so we get to use L'Hopital's rule. That will be our goal. So limit theta approaches to pi over 2 from the left. Tangent theta is sine theta over cosine theta minus secant theta is 1 over cosine theta. Great. We have a common denominator already. So that would be limit theta approaches to pi over 2 from the left. I have sine theta minus 1 over cosine theta. So sine pi over 2 is 1. And 1 minus 1 is 0. And cosine of pi over 2 is 0. So I have 0 over 0. So you get to use L'Hopital's rule. So now let's take the derivative, numerator, and the denominator. So I have limit theta approaches to pi over 2 from the left. Derivative of sine theta is cosine theta. Derivative of negative 1 is 0. Derivative of cosine theta is negative sine theta. So now you get to plug pi over 2, and cosine pi over 2 is 0. And negative sine pi over 2 is negative 1. So 0 over negative 1, which is 0. So our limit is 0. And answer for number 11 is A. Number 12. Given limit x approaches to 8 of 3 minus 4x. Find the limit and consider the epsilon delta proof. What is the value of delta? So we need to remind us what was the epsilon delta definition of limit was. So here was definition. It was given epsilon greater than 0, choose a delta positive number such that whenever absolute value of x minus c less than delta implies absolute value of f of x minus L less than epsilon, then we say limit x approaches to c of f of x is equal to L. This was a definition of limit using epsilon delta proof. So let's try to do this. So our c here is 8. It's easier if you can designate all those things. And then my function f of x is 3 minus 4x. We need to find L, and that's easy to do since all we have to do is plug it in. So let's plug it in here. Our limit will be 3 minus 4 times 8, which is equal to 3 minus 32, which is negative 29. So that is our L. L is negative 29. C is 8. And now we need to find right delta for that. So given epsilon greater than 0, choose delta equal, we don't know yet, we need to work it out. Choose delta, we don't know yet, that's what we're trying to find. So that whenever I have x minus c, which is 8, less than delta, would imply absolute value of my f of x is 3 minus 4x minus L, my L is negative 29, which is equal to absolute value of 3 minus 4x plus 29, which is equal to absolute value of 32 minus 4x. Now, I need to have this part, so I'm actually gonna factor out the negative 4. Then I have x minus 8 here, and this is equal to absolute value of negative 4 times absolute value of x minus 8, which is equal to 4 times absolute value of x minus 8, which is, by hypothesis, absolute value of x minus 8 is less than delta. So this would be less than 4 times delta, and I need that to be equal to epsilon. So since 4 delta has to be the epsilon, 4 delta has to be equal to epsilon, then delta has to be equal to epsilon over 4. So my answer would be C here, 1/4 epsilon. Number 13. Given limit x approaches to negative 2 of quantity x squared minus 4x plus 1. Find the limit and consider the delta epsilon proof. What is the value of delta? So this time we have quadratic function, and quadratic function involved factoring, and we had to let delta to be minimum of 1, and the delta we could find like we did the other problem. So let's do the problem. Given epsilon greater than 0, choose delta to be equal to minimum of 1 and the value to be found. And we are choosing that, of course, out of A, B, C, D, E choice since we don't have a 1 there. Then, whenever absolute value of x minus c, our c this time is negative 2, less than delta would imply absolute value of f of x, and our f of x is x squared minus 4x plus 1 minus L less than epsilon. And we need to find L here, and L can be found by plugging x equal negative 2 into your function. Let's find L. So that will be negative 2 squared minus 4 times negative 2 plus 1, which is equal to 4 plus 8 plus 1, which is 13. So our L is 13. So we are going to replace this L by 13 here. So now we have absolute value of x squared minus 4x plus 1 minus 13 is negative 12, which is equal to, it factors as x minus 6, x plus 2, and that's equal to absolute value of x minus 6, absolute value of x plus 2. And you notice absolute value of x plus 2 is this, since it's x minus minus 2, less than delta. So this part is less than delta, and we need to find a number appropriate to replace this absolute value. And that's why we're letting delta to be equal to 1. And if delta is 1, then as x approaches to negative 2, the delta neighborhood could be as small as delta equal 1, so it could be negative 3, and as large as 1 unit right of negative 2, which is negative 1. Then your absolute value of x minus 6, if you plug smallest possible x value here, I get negative 3 minus 6, which is equal to absolute value of negative 9, which is 9. And if you plug x equal negative 1, absolute value of x minus 6 could be negative 1 minus 6, which is equal to negative 7. And absolute value of negative 7 is 7. And we choose larger possible value of that because we're going to divide by larger number to determine the delta. So we get smallest possible delta. So we are going to say this has to be less than 9 times delta, because we have this hypothesis where absolute value of x plus 2 is less than delta. So we have that. And we want that to be equal to epsilon. So therefore, 9 delta equal epsilon. So divide both sides by 9. You can see that then delta has to be equal to epsilon divided by 9. So delta has to be minimum of 1 and epsilon over 9. So the value that we are looking for is epsilon over 9, which is B. Number 14, given limit x approaches to 6 of 2/3 x minus 5. Find the limit and consider the delta epsilon proof. What is the value of delta? So this one's the easy one since it's just linear, but let's get the L first. So my L is 2/3 times x, and my x is 6 minus 5. So 3 goes there twice. 2 times 2 is 4. Subtract 5, which is negative 1. So this is your L. Your C is 6. So let, given epsilon greater than 0, choose delta equal, we don't know yet, so that whenever x minus our C is 6 less than delta would imply absolute value of my function is 2/3 x minus 5 minus L is negative 1. So it became plus 1, which is equal to 2/3 x minus 4. So if you factor out the 2/3, it is 2/3 times x minus 6. Perfect. That's what we needed, right? So this is 2/3 times the absolute value of x minus 6, which is less than 2/3 times delta. So we want 2/3 times delta to be equal to epsilon. To solve for delta, we want to multiply both sides by 3 over 2. So here is your delta. Delta has to be equal to 3/2 epsilon. So answer is A. Number 15. Determine whether f has a discontinuity at x equals 7, and if so, explain why. My f of x equal x squared plus 3 if x is less than 7. It is 8x minus 4 if x is greater than or equal to 7. To determine discontinuity at x equals 7, we gotta use the definition of continuity. So recall the definition of continuity. F is continuous at x equals c if all three conditions are met. And first condition was whether f is defined at 7. Number 2, if limit x approaches to 7 of f of x exists, which means I gotta find out left limit of f of x as x approaches to 7 and the right limit of f of x as x approaches to 7 are equal to each other. And if so, then we can conclude the limit exists. And the third condition was number 1 and number 2 has to be the same, which means f of 7 has to be equal to the limit x approaches to 7 of f of x. So let's check to see if f is continuous at 7 or not. First condition, what's f of 7? We see 7 is included in this domain, so we're gonna plug it into this function. So f of 7 do exist, and it is 8 times 7 minus 4, which is equal to 56 minus 4, which is 52. Number 2, let's find out whether limit x approaches to 7 exists. To do that, like we said, we need to find out left limit and the right limit of f of x. So limit x approaches to 7 from the left. 7 from the left, x's are less than 7. So when x's are less than 7, we use quadratic function. So that's gonna be x squared plus 3, and that will be 7 squared plus 3, which is 49 plus 3, which is 52. The right limit of a function is when x approaches to 7 from the right. So 7 from the right, x's are bigger than 7, so we use 8x minus 4, which we already calculated earlier, and it was 56 minus 4, which was 52. So since my left limit is equal to the right limit, we see the limit x approaches to 7 of f of x exists, and it is 52. And third, once you already calculated f of 7 and the limit, all we have to see is if they match to each other. And because f of 7 is equal to the limit x approaches to 7 of f of x, which are both 52, we can see that this function is continuous at 7. And when it's not 7, it is a polynomial. So it is continuous on all real numbers when it is not 7. So therefore, we can conclude that f is continuous for all values of x. Number 16. Determine whether f has a discontinuity at x equals 6, and if so, explain why. F of x equal 3x squared minus 20x plus 12 all over x minus 6. So I have a rational function. Right off the bat, f of 6 is undefined. Yes? It's a 3 times 6 squared minus 20 times 6 plus 12 over 6 minus 6. Whether numerator is 0 or not, my denominator is 0, which is clearly undefined. So my f of 6 does not exist. Therefore, this function is not continuous at x equals 6. Because f of 6 does not exist is clearly one of the reasons why this function is discontinuous at x equals 6. And only A states that reason. I can stop here and not going any further for the problem. Number 17. Determine whether f has a discontinuity at x equals -2, and if so, explain why. So now I have a piecewise defined function with 3 pieces, and you can see it is all separated by x equals -2. So if I draw the number line, it might be a lot clearer. and here is -2. So when x equals -2, your function value is -8. And when x is less than -2, your function is 5x. When x is greater than -2, your function is x minus 8. Okay, so let's see if f is discontinuous or continuous at x equals -2. So first, what's f of -2? We just said f of -2 is -8. So it is defined. Number 2, what is the limit x approaches to -2 from the left of f of x? From the left, you can see it is 5x. So it's a 5 times -2, which is -10. What is the right limit? When x approaches to -2 from the right, we use x minus 8 function. So you plug -2 minus 8, again, it is -10. Yes, so since my left limit is equal to the right limit, limit x approaches to -2 of f of x exists, and it is -10. Number 3 is the function value at x equals -2 equals to the limit x approaches to -2 of f of x. No, right? F of -2 is -8, and limit is -10. And because of the third condition has not been met, we conclude that f is not continuous at x equals -2. So what is the reason here? That will be C here. Number 18. Determine whether f has a discontinuity at x equals -1, and if so, explain why. So this is two pieces. When x is less than -1, the function is 2x to the third power. When it is greater than -1, it is 2x squared. So, first condition, f of -1. -1 belongs to this domain. We use 2x squared. So 2 times -1 squared, which is 2 times 1. So it is 2. Number 2, limit x approaches -1 from the left. -1 from the left, we use 2x cubed function. When you plug it in there, -1 to the third power is 2 times -1, which is -2. Oh, right limit though. Remember, from the right, we use this function, and we did already plug it in number there earlier. So 2 times -1 squared was +2. And because my left limit is not equal to the right limit, limit x approaches -1 of f of x does not exist. And that will be the reason why this function is not continuous at x equals -1. So the answer is B. Number 19. Find the asymptotes for f of x equals x squared minus 25 over x squared plus 3x minus 10. So let's factor this first. X squared minus 25 factors as x plus 5 times x minus 5. X squared plus 3x minus 10 factors as x plus 5 times x minus 2. So we know f of x has a whole at x equals -5. And when it's not x equals -5, a function acts like x minus 5 over x minus 2. So to find out any asymptotes for f of x, we can find out one-sided limit knowing you do have a vertical asymptote at x equals 2. X approaches to 2 from the right or left. Your function is gonna go infinity or negative infinity, and we just need to show that, and we will know for sure we will have a vertical asymptote there. Of x minus 5 over x minus 2 is equal to, when x approaches 2 from the right, x is bigger than 2. So you can think of 2.0000001 or something. Minus 2 is almost to 0. That is a positive number. And 2 subtract 5 on the numerator is negative 3. So it's gonna go to negative infinity. And because x approaches to 2 from the right of x minus 5 over x minus 2 is negative infinity, we do have a vertical asymptote x equal 2. Because the degree of numerator is 2 and degree of denominator is 2, we know it has a horizontal asymptote. And the way we find the horizontal asymptote is we have to send the limit x approaches to infinity or negative infinity. If we get limit value as a number, then we have a horizontal asymptote. And the way we did it was we divide the numerator and denominator by highest power of the variable. So we're going to divide everything by x squared. So x squared divided by x squared is 1 minus 25 over x squared. 1 plus 3 over x minus 10 over x squared. So when you send the x to infinity, this goes to 0, this goes to 0, this goes to 0, and we get limit x approaches to infinity of 1 over 1, which is 1, and limit of 1 is 1. Thus, we have also horizontal asymptote y equal 1. So answer that has the vertical asymptote x equal 2 and horizontal asymptote y equal 1 is B. Number 20. If the limit x approaches to 4 from the right of f of x equals 7, then which is true? Well, when x approaches to c from the right or c from the left of f of x equal plus or minus infinity, then we have a vertical asymptote. So when x approaches to a real number c from the right or left, and you get a number there, it doesn't say anything. This limit does not indicate any asymptote. So the answer will be E. Number 21. If a limit x approaches to infinity of f of x equal 3, then which is true? You just saw limit x approaches to infinity of f of x gives you a real number k, then y equal k was a horizontal asymptote. And this is the same situation. We have a limit x approaches to infinity of f of x gives you real number 3. That means you're going to have a horizontal asymptote at y equal 3. So answer is B. Number 22. If a limit x approaches to 2 from the left of f of x equal infinity, then which is true? Well, then we have a vertical asymptote at x equal 2. So that is D. Number 23. Which statement is true for g of x equal 3x squared plus 2x minus 6 over x plus 4? This g of x, the numerator does not factor, and the degree of numerator is exactly 1 degree higher than the degree of denominator. So when we do the long division, if we get the remainder, then this function g has a slant asymptote, and the slant asymptote will be y equal the quotient. So let's try the long division. I have numerator 3x squared plus 2x minus 6 divided by x plus 4. So when I divide, x goes to 3x squared, 3x times. When you multiply, you get 3x squared. When you multiply, you get plus 12x. Now we need to subtract. When you subtract the top polynomial minus the bottom polynomial, negative needs to be distributed. That's how we subtract the polynomial. So it is 3x squared minus 3x squared, which 3x squared is gone. And it is 2x minus 12x, which is negative 10x. And then you can bring it down the next term, which is negative 6. And we do division all over again. X goes to negative 10x. How many times? It goes negative 10 times. So x times negative 10 is negative 10x. Positive 4 times negative 10 is negative 40. Now the top polynomial, subtract the bottom polynomial, and again you need to distribute the negative. So negative 10x make it positive here. Negative 40 makes it positive 40 there. So negative 10x and plus 10x gone. And negative 6 plus 40 is plus 34. And because I do have a remainder, this g of x has a slant asymptote, and it is y equal the quotient. And your quotient is 3x minus 10. So your slant asymptote is y equal 3x minus 10. So the answer is C. Number 24, which is the formula for the limit definition of derivative. So definition of derivative, you shouldn't be forgotten, right? This was very important, and it was limit delta x approaches to 0 of f of x plus delta x minus f of x over delta x. So the answer is D. Number 25. Use the limit definition of derivative and simplify the first few steps. Which limit will find f prime of x if f of x equal 2x squared minus 3x? So we're going to have to use definition of derivative, and while we do that, if we find any of these answer we get from the multiple choice of A through E, we will stop. So definition of derivative we just mentioned on number 25, and f prime of x is equal to limit delta x approaches to 0 of f of x plus delta x minus f of x over delta x, which is equal to limit delta x approaches to 0 of f of x plus delta x when you apply to f of x equal to x squared minus 3x, I get 2 times the input square minus 3 times the input minus the f of x, and f of x is 2x squared minus 3x over delta x. Now when you expand, I get limit delta x approaches to 0 of 2 times x squared plus 2x delta x plus delta x square minus 3x minus 3 times delta x minus 2x squared plus 3x over delta x. So when you distribute 2, I will get limit delta x approaches to 0 of 2x squared plus 4x delta x plus 2 times delta x squared minus 3x minus 3 delta x minus 2x squared plus 3x over delta x. So then 2x squared minus 2x squared gone. Negative 3x plus 3x gone. So all I have now is limit delta x approaches to 0 of 4x delta x plus 2 delta x squared minus 3 delta x over delta x, and I found same answer from C. So we will stop here. Number 26. Use the alternative form of limit definition of derivative. Limit x approaches to c of f of x minus f of c over x minus c, and simplify the first few steps. Which limit will find f prime of 3 if f of x equal x squared minus 4? So this alternative definition of derivative calculates f prime of c. So we use this when we wanted a derivative at specific point, like they ask f prime of 3. So to find that, I do want to have f of 3. So let's first to get the f of 3 to make our calculation easier. And f of 3, when you apply to your f of x above, it is 3 squared minus 4, which is equal to 9 minus 4, which is 5. So f prime of 3, according to the alternative definition, it is limit x approach to 3 of f of x, and our f of x is x squared minus 4 minus f of 3, and f of 3 we just found out it is 5 over x minus 3, since our c is 3. Then that is equal to limit x approaches to 3 of x squared minus 9 over x minus 3, which is equal to limit x approaches to 3 of x squared minus 9 factors as x plus 3 times x minus 3 over x minus 3. And when I cancel the common factor, I have a limit x approaches to 3 of x plus 3. And when you see the answer choice, they didn't actually found out the f prime of 3. They're asking when you do a few steps, which one of the following do you get? So you see the answer is E, and you can stop here.